Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P0976 and P0977 indicate issues with the Shift Solenoid Valve B circuitry in Honda Accord models from 2017 to 2023. DTC P0976 specifically refers to a low circuit signal, while DTC P0977 indicates a high circuit signal issue. These codes highlight the electrical aspects of the solenoid valve circuit and signify that the problem is not mechanical within the transmission. The shift solenoid valve is crucial as it controls the flow of transmission fluid, thereby impacting the vehicle's ability to shift gears smoothly. Its proper functioning is vital for efficient transmission operation. The solenoid and its circuit components are located within the transmission assembly and are typically accessed through the transmission fluid pan or housing. Accurately diagnosing these trouble codes is essential to ensure the longevity and performance of the vehicle's transmission system. The DTC P0976 signifies that there is a low signal reading from Shift Solenoid Valve B, whereas P0977 indicates a high signal. Both issues are rooted in the electrical circuitry rather than any mechanical faults within the transmission itself. The shift solenoid valve is located within the transmission assembly and is responsible for regulating the hydraulic pressure needed for gear shifting. It interacts with the transmission control module, TCM, by receiving electrical signals that dictate its operation. This module is typically located in the engine compartment or under the center console, facilitating communication between the engine and electronic transmission components. Understanding this circuitry will help pinpoint malfunctioning components and assist in determining repair procedures required to resolve these DTCs effectively. The potential causes for DTC P0976 and P0977 predominantly involve an electrical circuit malfunction rather than mechanical faults. Problems can arise from poor connections due to corrosion or loose terminals between the solenoid and the TCM, leading to disturbances in the signal transfer. Additionally, wiring issues such as short circuits or an open circuit could also contribute to these trouble codes. If the transmission control module, TCM, is malfunctioning, or if the solenoid valve itself is faulty, it may exacerbate these issues. Thus, it is critical to check the integrity of the electrical connections and wiring, as diagnosing these problems will also pave the way for identifying whether the solenoid or the TCM must be replaced. When either DTC P0976 or P0977 is triggered, the vehicle may exhibit several symptoms during operation. Drivers might notice difficulty in shifting gears, particularly if the solenoid circuits are compromised, which directly impacts the transmission's hydraulic pressure. The transmission warning light on the dashboard could also activate, alerting the driver of potential issues. In some cases, the vehicle may experience unexpected gear slipping or delay in shifting, further affecting overall driving performance. Understanding these symptoms helps the technician in diagnosing underlying issues and addressing them promptly to avoid further transmission complications. The first step in troubleshooting DTC P0976 and P0977 involves verifying the problem. Begin by turning the vehicle to the on mode without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear the existing DTCs from the system. Once cleared, conduct a test drive under specific conditions. For DTC P0976, ensure the engine is warmed up to its normal operating temperature and drive the vehicle in drive mode at approximately 37 miles per hour for at least 10 seconds. For DTC P0977, shift the transmission into park mode before starting the engine and wait for 10 seconds. This allows you to observe if the DTCs reappear, indicating a confirmed issue rather than an intermittent failure. In the second troubleshooting step, focus on identifying the failure area related to DTCs P0976 and P0977. Start by turning off the vehicle and disconnecting the TCM50P connector, which serves as a crucial connection point for the solenoid valve's electrical control. Following this, check for continuity between test points 1 and 2 to assess electrical connectivity. Test point 1 should correspond to TCM50P connector number 7. While test point 2 is the body ground, a continuity reading of 10.6 to 13.5 ohms is acceptable, indicating that the electrical circuit is functioning correctly. If the resistance falls below 10.6 ohms or exceeds 13.5 ohms, further steps are required to identify the specific electrical fault before proceeding. Step 3 entails verifying the SOLB line for any short circuits that may contribute to the DTCs. Begin by disconnecting the Shift Solenoid Valve B 2P connector to isolate the circuit. Again, check for continuity between test points 1 and 2 with the vehicle in the off mode and both the Shift Solenoid connector and TCM connector disconnected from the system. If continuity is established, this confirms that the wire has a short to ground condition between the solenoid and the TCM. In this case, immediate repairs are necessary to rectify the short condition. Conversely, if there is no continuity, the SOLB wire remains intact, which suggests that the issue lies within the Shift Solenoid valve itself. Thus, the valve body assembly should be replaced accordingly. The final troubleshooting step focuses on checking for open wires within the SOLB SHB plus line, which could be responsible for the DTCs being triggered. Similar to the previous steps, start by disconnecting the Shift Solenoid Valve B 2P connector. You must check for continuity between specific test points, ensuring that both the solenoid and TCM connectors are disconnected from the vehicle system during this procedure. Test point 1 is designated as the female terminal number 1 of the solenoid connector, while test point 2 is the TCM50P connector number 7. A continuity reading at this stage confirms the integrity of the SOLB SHB plus wire. If continuity is confirmed, then the fault lies with the Shift Solenoid Valve B, and the valve body assembly must be replaced. If no continuity exists, there is an open wire that needs to be repaired in the SOLB SHB plus circuit. Upon completing all repairs related to DTC P0976 and P0977, it's essential to verify that the repairs have resolved the issue. Begin this final verification by rechecking for any confirmed DTC codes using the Honda Diagnostic System, HDS. This step ensures that the previously triggered trouble codes do not reappear, indicating successful repairs. Additionally, test the operation of the transmission to confirm that all shifting functions are now performing smoothly, without interruptions or warning lights being triggered. If all systems operate correctly and DTCs have been cleared, this confirms that the repairs were effective. Always remember to document the entire diagnostic and repair process for future reference and any required follow-up. For preventative maintenance regarding the transmission control module and its associated components, several proactive strategies are recommended. Regular inspections of the solenoid valve connections are vital in mitigating any potential electrical issues. This involves thorough checks for signs of corrosion, wear, or loose connections that could lead to malfunctions. Keeping connectors clean and free from grime can enhance electrical connectivity and prevent future trouble codes from emerging. Additionally, staying on top of regular vehicle service intervals and ensuring that the transmission fluid is at optimal levels can improve the longevity and performance of the system. Establishing a preventive maintenance routine allows for timely identification and resolution of minor issues before they escalate into larger problems. In conclusion, correctly diagnosing DTCs P0976 and P0977 is essential for maintaining the functionality of the Honda Accord's transmission system. Both trouble codes highlight electrical issues rather than mechanical problems, requiring focused troubleshooting strategies to identify faulty components. Common causes include poor electrical connections, faulty wiring, or defective solenoid valves, all of which must be addressed promptly to avoid more significant failures. Employing a preventative maintenance approach can help avoid these issues in the future by ensuring all electrical connections are sound and regularly inspected. By adhering to the diagnostic steps outlined and implementing preventive strategies, vehicle longevity can be enhanced and operational efficiency ensured. Please like and subscribe to the channel. See you next time.